All right, so welcome back to the last section of the fluid mechanics portion of the Civil FE exam review. Today we're going to be looking at energy, impulse, and momentum of fluids. So I got some interactive problems for today that aren't super complicated, but let's go ahead and get into them. So number one says, the density of air flowing in a duct is 1.15 kilogram per meter cubed. A Pitot tube is placed in the duct as shown. The static pressure in the duct is measured in a wall tap and pressure gauge. Use the gauge readings to determine the velocity of the air. All right. So what are we trying? What are we given? Right. Well, we're given the density of air. We are also, what else are we given? We're given pressure readings. Of the static pressure coming in and out. Right. Okay. So we're also given that this is a Pitot tube. Right. What are we trying to find? Right. We're trying to find the velocity of the air. So, velocity. Okay. Are there any formulas that we need? Well, first and foremost, let's also get these readings. For those of you who it's kind of hard to see, it's like it's coming in at 6 times 10 to the third pascals. And it's going out at 7 times 10 to the third pascals. Okay. So those are our readings coming in and coming out. All right, so let's start by just searching Pitot tube because I don't see if we can find a formula that we can use. So I do a search. All right, Pitot tubes. Okay, so V is the velocity of the fluid. Well, in this case, it's going to be air, but the stagnation pressure and the static pressure. So of the fluid at the elevation where the measurement is taken. So PS is the start, and P0 is where it ends. All right, so it ends. So this would be our P0, and the static pressure, the fluid at the where the measurement is taken, is here. So that's going to be our PS. Okay. And what else is in this formula? So we get the velocity of the fluid. So V is equal to square root 2 over the density. That's what rho stands for. Times P0 minus PS. Now, do we know what rho is? Yes, we know the density of the air, right? This is rho. All right, so we have rho, we have P0, and we have PS. Now it's just time to solve, right? All right. So when I solve this, I get square root of 2 over 1.15 kg per m cubed. Okay. And then 7 times 10 to the third PA minus 6 times 10 to the third PA. Okay. So we have to know that our units don't match. So once we bring this over, we get, and I'll just bring this up here. It's going to transfer everything that we're doing up here. So I get 2 square root of 2 over 1.15 kg m to the third times 1,000 pascals. Right. All right. How do we get pascals to go into kilograms, or get some units to cancel, right? All right. So let's go to our unit conversions section to see if that'll help us. All right. So 1 Pascal equals 1 Newton per meter squared. So we'll start there. So 1 Pascal is equal to what is it? Newton over meter squared. So 1 Newton over meter squared. Okay. So I'll be able to switch that unit into Newton over meter squared, but that's still not going to cancel out my units completely. So is there anything, can I get this Newton? What is a Newton? So 1 Newton, and we'll change the color. So 1, can we get that in kilograms or something so that units can start canceling? So 1 Newton is equal to 1 kilogram times meters over second squared. One kg m over second squared. Okay, so now let's take this and substitute it into our newtons. All right. So now 1 Pascal. So 1 PA is equal to 1 is equal to 1 kg times m over s squared. And then all of that over meters squared. And so that simplifies to it just being kg over m dot s squared. Okay, so 1 kPa equals 1 kg over meters times second squared. All right, cool. Now that we have all of that, now we know that we can substitute these units into here. We just want units. We just want units that will make sure that things cancel. All right. All right. So let's do some erasing. Hopefully you wrote this stuff down. All right. So the last step would just be us, again, substituting the values that we need. And this is all for velocity, right? So get velocity is equal to square root 2 over 1.15 kilogram per meter cubed times 1,000. Instead of PA, we're going to put kg over m times s squared. All right. And all of this is going to unit wise is going to be should be meters to the these are going to cancel, right? So we're going to get our answer in a meter squared over, our units are going to be meters squared over second squared. We're going to take the square root of that, and it's going to give us our meters over seconds. And so the answer is going to be 41.7 meters per second. So units are the main thing here. We want to make sure that we have the right units. And so that was very tricky, but we do all that because we want to make sure that we fully understand what we're doing. So our answer is going to be A, closest thing to the answer. Not a hard problem, just a lot of unit conversions. So I hope that you're enjoying this video. I just wanted to drop in and say, if you're looking to pass your Civil FE exam within the next 90 days, then you definitely want to check out the course that I've created. The video that you're currently watching gives you just a glimpse of what is in the course, and I have made it test taker proof. And what that means is no matter if you've been out of school for a while or you just have trouble with some of the engineering concepts, if you study this material that is in the course, it will help you to pass within the next 90 days. There are also full practice exams. Yes, 110 question practice exams, along with review guides and study schedule templates to help you pass. And these are resources that I have created for you. So if you want to check out any of those, just head down in the description box below and check them out now. Now, to stay up to date on any new videos that I drop, whether it is more practice problems like in this video, or if you want advice and some extra tips to help you pass your Civil FE exam, you're gonna wanna make sure that you hit that subscribe button, turn on those bell notifications so that you know exactly when I post. And if you wanna check out the next video, you can here.